Hello, class. So today we're going to be going over Module 3.2, proving figures are congruent using rigid motion. So just follow along in the worksheet I provided. This is going to be your notes for today. So let's get on to our first example here. Are the two figures congruent? So what we're going to be doing today is showing or pretty much proving if two figures are congruent. And by congruent, I mean are the two figures identical? And by showing to show that they're identical, you can have to show that their side lengths stay the same as well as their angle measures. So if you look on the left side, the two quadrilaterals there, quadrilateral ABCD and EFGH, you're trying to figure out, are those two congruent? And just by looking at them, they are. But why are they congruent? So a few things that we're going to look for here is angle measures and side lengths as well. The quickest one to see here is the side lengths. So if I look at side DA and side HE, those two are congruent to one another. Again, if you were to take a ruler, do the distance formula, work it out, it'll prove that those two sides have the same length. Same thing goes for side AB and side EF. Same thing for side BC down here and side FG. So those sides with each correspond to one another. They're congruent, same length. Same thing for side DC and side HG. And once we kind of show that two figures are congruent, we want to write out a congruency statement. And it's just a statement stating that the two figures we see in front of us are congruent. And the way you write that is what's shown below. So we write out the name of the shape. In case it's a quadrilateral, so it's ABCD. It's followed by this sign, which is a congruent sign, just an equal sign with a little squiggly sign on top. That just means congruent, followed by the name of the second figure we're working with, which in this case is figure EFGH. So this is pretty much stating that these two shapes are congruent to one another. Now, if you look on the right side, the two triangles over here, triangle MNL and triangle EFD, both of those, if you just look at them, you can easily tell they're not congruent. And one way that gives it away is if you compare two corresponding sides. So if I go with ML and ED right here, you can clearly see that one is a lot longer than the other. They're not the same length. So side length was not preserved here, which means that these two figures are not congruent. And if they're not congruent, you still write a congruency statement, but you state that the two figures, in this case the two triangles, are not congruent. And the way you write that out is like this. Just give the name of the one triangle, MNL, and then you follow it by the not congruent sign. It's just a congruency sign with a slash through it, and then you write the name of the second shape, which was EFD. Okay, so let's move on to the next problem. So this next one, I want you guys to just take a few moments on your own and write out the congruency statements for these two sets of figures. So again, if they're congruent, show me a congruency statement that's saying they are. And if they're not, show me a congruency statement saying that they're not congruent. So just take a few moments right now. You could pause the video before you move on. Okay, so I guess it's into the next topic. It's called rigid motion to show congruence. And again, if you remember what rigid motion is when the pre-image and the image remain identical to one another after we perform a transformation on them. And remember, a rigid motion preserves side length and it also preserves angle measure. And that's enough to show congruence. So our first example here, is you want to use rigid motion to show congruence. So if you look at the two quadrilaterals here, we're trying to prove, are they congruent to one another? And right here, if you look at them, they are. The side lanes were preserved as well as the angle measure. But we want to kind of give a little bit more information. We want to prove it using your rigid motion. And the rigid motion here was looks like it's a y-axis reflection. Again, I didn't tell you which one's the pre-image and which one's the image. So I'm just going to pick one to be the pre-image, one to be the image. And I'm going to say quadrilateral DCFE was reflected across the y-axis to get the quadrilateral KJML. So what you want to do here to show that they're congruent, start off by writing out your congruency statement. So we said quadrilateral DCFE is congruent to quadrilateral KJML. And how are they congruent? By a y-axis reflection, and also give the rule for the reflection, the y-axis reflection, which is xy to negative xy. Okay, let's get on to the next example. Again, you want to show rigid motion here, where rigid motion occurred to show congruence. So if you look at the two quadrilaterals here, I'm going to say that quadrilateral ABCD is my pre-image, which means that quadrilateral WXYZ is my image. And it looks like it was reflected down across the x-axis, showing that they're congruent. The reflection, again, remember, is rigid motion. So we'll start off by writing out your congruency statement. ABCD congruent to WXYZ. Give the reason or the rigid motion that you used, which was an x-axis reflection, followed by the rule. All right, let's go to the next one. Okay, so we want to show that these two triangles are congruent by rigid motion. So again, I didn't tell you which one is the pre-image, which one's the image. Depending on which one you start with, it'll give you a different type of transformation here. Again, here, what I'm going to do is I'm going to say that triangle WXZ is my pre-image and triangle BAC is my image. And remember, here it looks like it did a rotation, and we're always doing our rotations here counterclockwise. So if I start here in my pre-image and I rotate it, looks like it went 3 quadrants around the origin counterclockwise, which will make it a 270-degree counterclockwise rotation. And again, remember, a 270 rotation is rigid motion, which means that these two triangles are congruent to one another. So start off by writing out your congruency statement, YXZ congruent to BAC, and then give a reason, which was a 270-degree counterclockwise rotation. And again, give the rule, which is xy to y negative x. Okay, let's go on to the next example here. So what I want you guys to do here is work this one out your own. Prove that one figure is congruent to the other by a rigid motion. So what I'm going to have you do is say that quadrilateral WXYZ is the pre-image and is being mapped to quadrilateral EFGD. So again, write your congruency statement and give me what rigid motion you used. So again, pause the video now, work the problem out, and then show me before moving on. Okay, so our last topic we're going to go over is called a sequence of rigid motions to show congruence. And what a sequence of rigid motions is, it's more than one rigid motions performed from the pre-image to the image to show congruence. So in the previous examples, there was just one rigid motion. and these is going to be one or more rigid motions to show congruence. So if we start with the first example here, we have two triangles here, triangle ABC and triangle PQR. So I provided you with a congruency statement on top, just saying that these two triangles are congruent. What we need to do now is prove why are they congruent. So if we start with that, starting with, because since I wrote triangle ABC first, let's assume that's the pre-image, and we need to get to triangle PQR, which is our image. And if you look at the transformation that must have occurred here, or the rigid motion that occurred, it was a rotation. And here, if you go counterclockwise, it goes over two quadrants, which makes it a 180-degree rotation. So if I were to perform the 180-degree rotation, and I rotate triangle ABC, I'll end up right there where that red triangle is at. But if you notice, that red triangle doesn't map exactly to triangle PQR. It's not directly above it. It's a little bit to the side of it, which means that we need to do another transformation to get there. And what it looks like it's happening here is it needs to go to the right 1 unit. So that means that those are the two transformations that happened. So let's start off with the first one. We said it was a 180-degree rotation. So we write that out. So we said it's a 180-degree rotation around the origin. So give the rule. And then we said it needed to move to the right, like 1 unit. So if I move it to the right 1 unit, here's my triangle. They're one in green. So clearly now it got mapped onto PQR. So this was a translation of 1 unit to the right, 0 units up or down. So we give the transformation, the rigid motion that happened here, which was a translation, 1 unit to the right. And then you give the rule in vector form here, which is 1, 0. Okay, so let's move on to the next problem. So again, I want you guys to try this on your own. And then I want you to show me the solution before moving on. So the problem tells you that quadrilateral JKLM is your pre-image. And you want to get to the image, which is at WXYZ. So somehow it went from up here down here. So remember, it's a sequence of one or more transformations. And here it's going to be more than one because we're doing a sequence. So again, take a few moments, work it out. The congruency statement is already there. Just give me the rigid motions you use to get from one triangle or quadrilateral, to the next one. So again, pause the video, work it out, and show me your solution before moving on. Okay, here's our next one. Again, do the same thing as before. The previous example, you want to show me if these two triangles are congruent to one another. And again, I didn't give you a congruency statement. I didn't tell you which one's the pre-image. So I'm going to leave it up to you to pick which one's your pre-image and try to get to the other triangle to get your image. So again, work this out and show me your work before moving on. So you could pause the video right now and work your problem out. Okay, class, so we got to the end of our notes. So just make sure you show me your notes so you could get your credit and your stamp on there. And what I want you guys to do right now, just to be sure that you're listening to the notes, to the video, on the last page of your notes, I want you to write down your favorite animal and your favorite color before showing your notes to me.